Question 1. Consider the network diagram. Which vertex has degree 4? The points A to F are known as vertices or nodes. And degree represents the number of connections at each particular node. Now the question is, which vertex or node has degree 4? In other words, which of these points, A through to F, has 4 connections? And by inspection, we can see that node or vertex B has 4 connections in total. So 1, 2, 3, and 4. Therefore, the correct answer is option B. Question 2. Which graph could represent y equals 4 to the power of x? Consider the form of the equation. We have the variable y is equal to a number to the power of the variable x. This means there is an exponential relationship between the variable y and the variable x. Looking at the base, we have a base of 4, and it is greater than 1. That means as we move from left to right on the graph is getting steeper and steeper. And out of the 4 options, the only option that shows this particular property is option A. Now for completeness, if we consider the other options, looking at option B, we have y equals a to the power of x. It is a type of exponential relationship. However, the base A is a value between 0 and 1. Looking at option C, this is a straight line graph, and it's of the form y equals mx plus c, where m, the gradient, is less than 0 or negative. And looking at option D, this is of the form y equals mx plus c, where m, or the gradient m, is greater than 0 or positive. Question 3. The network shows the distances in kilometers along a series of roads that connect towns. What is the value of the largest weighted edge included in the minimum spanning tree for this network? The first thing we need to do is to complete the minimum spanning tree, and I'm going to use Kruskal's algorithm to do so. So starting with the smallest weighted edge, we have a 4, so I'm just going to circle that. Now the next highest edge is a 5, and we also have this 5 here. So using either Prim's or Kruskal's algorithm, it's important that as we're selecting edges that no cycles are created. The next highest weighted edge after 5 is 6. Now this means that I can't choose this 7 here or this 7 here, because then a cycle is created. So here and here. Now I can't choose 8 either, because that creates a cycle here as well. So the next highest edge that I can pick is 9. And those that I've circled connect all the nodes or the vertices together, and we could make sure of that. So whichever node I choose, we should be able to get to every other node. So if I start here, I can get to this node there, I can get to this node there, I can go this way, this way, this way to get to this node, I could go this way, and this way to get to this node, and I could go this way, and this way to get to that node there. So the highest or the largest weighted edge included in this minimum spanning tree for this network is 9. Therefore, the correct answer is option C. Question 4. Frankie takes 4 weeks of annual leave. His weekly pay is $350 and his annual leave loading is 17.5% of 4 weeks' pay. What is Frankie's total pay for this period of annual leave? Frankie earns $350 per week. So to find how much Frankie earns over 4 weeks, we multiply 350 by 4. We then need to increase this amount by the annual leave loading percentage of 17.5% or 17.5%, because on top of the normal 4 weeks pay, he earns an extra 17.5% on top for the annual leave loading. And we can do that all in one step. So 350 times 4 gives us how much Frankie earns normally over 4 weeks, and then increasing that by 17.5%, we could multiply this amount here by 117.5%. And that gives us $1,645, which is Frankie's total pay for this 4 weeks of annual leave. Therefore, the correct answer is option D. Question 5. Which of the following is arranged from largest to smallest? These values are in scientific notation or standard form. To arrange them from largest to smallest, consider the powers of base 10 and in particular the indices of the base 10. And we want those indices to be arranged from largest to smallest. Looking at all 4 options, option D has the indices arranged from largest to smallest. -1 is larger than -3, which is larger than -4. For completeness, I've expressed these values in ordinary decimal form. 3.2 times 10 to the power of -1 is 0.32. 6.2 times 10 to the power of -3 is 0.0062, which clearly is smaller than 0.32. And 4.5 times 10 to the power of -4 is 0.00045, which is smaller than 0.0062. Therefore, the correct answer is option D. Question 6. Consider the formula N equals M minus P over Q. Which of the following correctly shows P as the subject of the formula? We'll start by moving the variable Q from the right-hand side to the left-hand side. Now on the right-hand side we have a fraction where Q is the denominator. This implies that M minus P is being divided by Q. Now when we move Q over to the other side, we need to do the opposite of division, which is multiplication. So the N that's currently there is going to be multiplied by Q. So the formula becomes N times Q, or NQ, is equal to M minus P, which was the numerator of the fraction on the right-hand side. Now we want the variable P to be on the left-hand side because the subject of a formula by convention should be on the left-hand side and isolated on its own. So on the right-hand side, we have minus P. When we move minus P over to the other side, it becomes positive or plus P. Another way to think of that is if we add P to both sides of this equation, negative P plus P equals 0. So we end up with M on its own on the right-hand side, and then we end up with a positive P on the left-hand side. So the formula becomes P plus NQ is equal to M. Now in our final step, we can move this group of variables, so NQ, because they're being multiplied together, that can be moved in one step over to the right-hand side. So NQ is being added to P. We're going to subtract NQ from both sides of the equation. So this plus NQ, basically what happens is that it moves to the other side and becomes minus NQ. So the rearranged formula with P as the subject is P equals M minus NQ. Therefore, the correct answer is option B. Question 7. There are 960 students at a high school. Using stratified sampling, 240 students from the whole school are to be chosen for a survey. If there are 200 students in Year 12, how many Year 12 students should be chosen? we need to work out what fraction of the whole school are Year 12 students. Now, if we go back to the question, the first line tells us how many students there are in total, and there are 960 students, of which 200 of those students are in Year 12. So the fraction of the whole school that are Year 12 students is 200 over 960, which simplifies to 5 over 24. So 5/24 of the entire school are Year 12 students. So it stands to reason that 5/12 of the sample, so 5/12 of the 240 students that are going to get chosen, should also be Year 12 students, so that the Year 12 cohort is fairly represented. So the size of the sample is 5/24 of 240, which is 50 students. So 50 students out of the 240 students should be chosen to be part of this sample. Therefore, the correct answer is option C. Question 8. A spinner made up of 4 colours is spun 100 times. The frequency histogram shows the results. Which of these spinners is most likely to give the results shown? Looking at the histogram, the heights of the columns for red, white, green and yellow are all different, with white being the tallest column, that occurs the most often, and green being the shortest column, that occurs least often. So looking at the sectors that make up these spinners, this implies that the sectors for those 4 colours will be of different sizes. So looking at option B, the sectors for red, green, yellow and white are equal in size. So option B is incorrect because the columns that represent those colours are all of different heights. Also, option C, yellow, green and red, those sectors are equal in size, which implies that the columns for red, green and yellow will be equal in height. But on the histogram, they're different heights. So option C is also incorrect. That leaves us options A or D to consider. Looking at option D, the white sector is equal in size to the red sector. But going back to the histogram, the column for white is taller than the column for red. So option D is incorrect, which means that the only correct option is option A. And looking at the size of the sectors, white should be the largest sector, followed by red, followed by yellow, and then followed by green. Going back to the histogram, we can see that those columns are in corresponding height, with white being the tallest column, red being the second tallest column, yellow being the third tallest column, and green being the shortest column. Question 9. The ratio of the dimensions of a model car to the dimensions of an actual car is 1 to 64. The actual car has a length of 4.9 meters. What is the length of the model car in centimeters, correct to 1 decimal place? The question is asking for the length of the model car in centimeters, which means all measurements should be converted to centimeters where necessary. Now, the actual car has a length of 4.9 meters. So we're going to convert 4.9 meters into centimeters first. Now, 4.9 meters, if we multiply that by 100, because there are 100 centimeters in 1 meter, we get 490 centimeters. Now, the scale that's given here is 1 to 64. That means the model car is 64 times smaller than the actual car, which means we'll take the actual measurement of the car, which is 490 centimeters, and we'll divide that by 64 to get the length of the model car. And we get 7.65625 centimeters, which rounds to 7.7 centimeters, correct to 1 decimal place. Therefore, the correct answer is option B. Question 10. An electricity company charges customers 37 cents per kilowatt hour for electricity used, U, and pays customers 5 cents per kilowatt hour for electricity produced, P. The electricity company also charges customers a fee of 71 cents per day. Which formula should be used to calculate a customer's daily cost of electricity, C, in cents? Let's look at the wording of the question and in particular taking note of certain key words. Now the first key word that I've underlined is charges. That appears here and here. The next key word is pays and it appears once here. Finally, daily cost appears here, which is what C represents in the formula. So let's go back to the beginning. An electricity company charges customers 37 cents per kilowatt hour for electricity used, U. So U represents the number of kilowatt hours. For each kilowatt hour, it's 37 cents. So the charge for the energy used is 37 times U. And that's why if you look at all four options, they have a 37U as one of the terms. Now, because C represents a charge, it's what the customer has to pay, the 37U has to be positive because we're adding to the charge. That's why I underlined this key word here, charges. So the formula has to contain a plus 37U. Immediately, options C and D are out. So it's only options A and B that we need to consider. Now let's look at this word here, charges, which appears in the third line. Charges customers a fee of 71 cents per day. Now, that's a flat rate. In other words, regardless of any energy used, there's 71 cents that's added to the charge. And if you notice, all four options have a 71 in them. So this line here doesn't differentiate between any of the options. But this keyword here, pays, is what's important. So for any electricity produced, there's a refund, which is what this word implies, of 5 cents per kilowatt hour, which is represented by P here. That's the number of kilowatt hours of electricity produced. So we need to take away from the charge, which means there must be a minus or a negative 5p somewhere. So out of the options A or B, only option A has a minus 5p in it. Therefore, the correct answer is option A. Question 11. The thickness of the skin of a spherical balloon varies inversely with the surface area of the balloon. What would be the effect on the thickness of the skin if the radius of the balloon is doubled? I've underlined two key terms that we need to take special note of. Now, the first one is varies inversely. So let's say y varies inversely with x. That means when x is doubled, y is halved. If x is halved, then y is doubled. So it works like a seesaw. So in this case, the thickness of the skin of the spherical balloon varies inversely with the surface area of the balloon. So as the surface area of the balloon increases, the thickness of the skin of the balloon decreases. It gets thinner. So if the surface area were to double, the thickness of the skin of the balloon would halve or would be divided by 2. So immediately looking at the four options, option B and option D are out because that implies that multiplied by 2 and multiplied by 4 that the thickness of the skin would increase as the surface area of the balloon increases, which is clearly wrong. Because varies inversely, as I've stated before, means as the surface area is increasing, the thickness of the skin is decreasing. So we need to consider options A or C. Let's look at the surface area formula for a sphere. Now, surface area, that's what SA means here, is equal to 4 times pi times radius squared. Now, the radius of the balloon is doubled. I've underlined doubled here as the other key term. So if we go back to the R in the formula here, what happens when we double the radius? Now, the surface area does not double. The surface area, in fact, increases by a factor of 4. which means option A is incorrect. So the only viable option is option C. Question 12. A football game is being played in Quito, UTC -5, starting at 3:40 p.m. on Tuesday. What is the time in Sydney, UTC +10, when the game starts in Quito? Quito is 5 hours behind UTC and Sydney is 10 hours ahead of UTC. So the difference between +10 and -5 is 15 hours. And because Sydney is +10 UTC, Sydney is ahead in time relative to Quito. And the difference between +10 and -5 is 15 hours, so Sydney is 15 hours ahead of Quito. So the game is played 3:40 p.m. on Tuesday in Quito, and we need to add 15 hours to that time. So if we take the time in Quito, so it's 3:40 p.m. on a Tuesday, if we add 12 hours, we get to 3:40 a.m. the next day. So 3:40 a.m. on Wednesday in Sydney, but we want 15 hours. So we need to add another 3 hours to that. So 3:40 a.m. plus another 3 hours to get the 15 hours ahead, and we get 6:40 a.m. on a Wednesday. Therefore, the correct answer is option D. Question 13. A 10-sided die has faces numbered 1 to 10. The die is constructed so that the probability of obtaining the number 1 is greater than the probability of obtaining any of the other numbers. The numbers 2 to 10 are equally likely to occur. When the die is rolled 153 times, a 1 is obtained 72 times. By using the relative frequency of rolling a 1, which of the following is the best estimate for the probability of rolling a 10? The experimental probability of rolling a 1 based on the result of this particular experiment is 72 over 153, which simplifies to 8 over 17. And we get that from this line here. When the die is rolled 153 times, a 1 is obtained 72 times. So it's almost 50% of the time. Let's consider the probability of not rolling a 1. In other words, rolling a 2, 3, 4, 5, 6, 7, 8, 9, or 10. By the law of complements, the probability of not rolling a 1 is 1 minus the probability of rolling a 1. So 1 minus 8 over 17 is equal to 9 over 17. Now going back to the question, the die is constructed so that the probability of obtaining the number 1 is greater than the probability of obtaining any of the other numbers, and the numbers 2 to 10 are equally likely to occur. And the question is, use the result of this experiment to estimate the probability of rolling a 10, which is one of those other 9 outcomes. So going back to this line here, the probability of not rolling a 1 is 9 over 17, but we want one of those outcomes that's not a 1, which is 10. So the probability of rolling a 10, which is equal to the probability of rolling a 9, an 8, a 7, and so on, is 9 over 17, because that's the sum of the probabilities of all those outcomes other than 1, dividing that by 9, and we get 1 over 17. Therefore, the correct answer is option A. Question 14. Points M and P are the same distance from a third point R. The bearing of M from R is 17 degrees and the bearing of P from R is 107 degrees. Which of the following best describes the bearing of P from M? This question is best answered diagrammatically. Now, I've tried to draw this somewhat to scale. I've started by drawing a north-south and an east-west set of axes, Point R is the origin or the center where the two axes meet. And I've shown point M here with a bearing of 17 degrees true. So that's an angle of 17 degrees measured clockwise from north. And I've shown that here with the arc. And here is point P with a bearing of 107 degrees true. So that is an angle measured from north clockwise until we strike this line here, or this interval RP. Now, it just so happens that 107 degrees is 90 degrees more than 17 degrees. So there's 90 degrees between the bearing of point M and the bearing of point P. Now, I've shown that with a 90-degree symbol here. Now, the question is, which of the following best describes the bearing of P from M? Now, I've shown the distance MR and PR to be roughly the same. I've drawn a north-south axis through point M. So this north-south axis is parallel to this north-south axis here through point R. And we want the bearing of P from M. That's why I've drawn the north-south axis through point M. And the bearing is measured clockwise from north, so from this axis here, measured around until we strike interval MP. Now, clearly from this diagram, this bearing here is greater than 90 degrees, so it can't be option B. It can't be option D either because it hasn't struck the south axis, so we haven't reached that yet. So neither B or D are correct. And it's clearly greater than 90 degrees, as we can see from the diagram, because there's east that way, and we've gone beyond east. So the correct answer is option C. Question 15. The minimum daily temperature in degrees of a town each year follows a normal distribution with its mean equal to its standard deviation. The minimum daily temperature was recorded over 1 year. What percentage of the recorded minimum daily temperatures was above 0 degrees? There are two important things to note in this question. Now, the first one is that the minimum daily temperatures follow a normal distribution. So that's a stereotypical bell curve, which means we may have to use the empirical rule to work out percentages of scores between any particular 2 points, which may mean we need to work out z-scores. So I'm sort of thinking ahead here as to what we might need to use later on. Now, the next thing to note is that the mean temperature is not stated. We don't know what it is. All we do know is that the mean is equal to the standard deviation. Now, because the scores, which represent temperatures, follow a normal distribution, we know that the standard deviation can't be 0, nor can it be negative. Has to be a positive number. It doesn't have to be an integer or a whole number, but it must be positive. And the question is asking for what percentage of the recorded minimum daily temperatures was above 0 degrees. So I'm thinking here that we need to calculate a z-score at some point. But we need a value for the mean, mu, and the standard deviation, sigma. So that's mu and sigma. So I'm going to let mu equal sigma equal 3. Now, 3 is just a random positive number. It doesn't matter what you choose here, as long as it's positive. If we wanted to make it easy on ourselves, we could have just chosen 1. But I've just chosen 3 just to show you how this works. The next thing is we need to work out a z-score for 0 degrees Celsius using the z-score formula. And we get z equals 0 minus 3, so that's 0 degrees minus the mean, which we chose up here, which is 3 degrees, in brackets, divided by the standard deviation 3, since mu is equal to sigma, so mean is equal to standard deviation, which equals 3, and we get negative 1. Now, it doesn't matter what value we choose here. We're always going to get a z-score of negative 1 using this formula and using 0 here. So we want the percentage of scores that lie above z equals negative 1. Now, using the empirical rule, we know that the percentage of scores between z equals -1 and z equals 1 is 68%. So between z equals -1 and z equals 0, we have 34, or roughly 34% of scores. Now, above z equals 0, that whole half of the bell curve or the normal distribution, we have 50% of the scores. So 34%, so that's from z equals -1 to z equals 0, plus 50%, which is all scores above z equals 0, gives us 84%. Therefore, the correct answer is option D. Question 16. Paint is sold in 2 sizes at a local shop. 4-litre cans at $90 per can and 10-litre cans at $205 per can. Mina needs to purchase 80 litres of paint. Calculate the amount of money Mina will save by purchasing only 10-litre cans of paint rather than only 4-litre cans of paint. There are 2 cases to consider. In case 1, Mina buys only 4-litre cans. So to work out the cost, we need to work out how many cans she needs to purchase. So she needs 80 litres of paint. Each can has 4 litres of paint. So to work out the number of cans, we take 80 and then divide that by 4. Now 80 divided by 4, of course, is 20. And then we multiply that by the cost per can, which is $90. So the cost of using only 4-litre cans is $1,800. Now let's consider case 2. Mina uses only 10-litre cans. Now we know that the cost is going to be less, and that's because it's stated here. Calculate the amount of money Mina will save. So we know that case 2 is going to be cheaper, but we need to work out obviously by how much. So to work out the cost, we follow a similar process to case 1. 80 divided by 10, so 80 litres of paint that we need in total, and there are 10 litres of paint in each can. So 80 divided by 10, of course that's 8. Multiply that by the cost per 10-litre can, which is $205, and we get $1,640. So to work out the cost saving, we work out the difference between case 1 and case 2. So case 1 minus case 2, since case 1 is more expensive, $1,800 minus $1,640 gives us a cost saving of $160. Question 17. The scatter plot shows a bivariate dataset where x is the independent variable and y is the dependent variable. The points 0,14 and 5,4 lie on the line of best fit. Plot the points 0,14 and 5,4 on the graph and hence find the equation of the line of best fit. Here is the point 0,14 and here is the point 5,4. Now I've drawn the line of best fit that passes through both of those points, noting that this point here, 0,14, lies on the y-axis, which means this point is the y-intercept of the line, and we'll need that later on in order to find the equation of the line of best fit. But in order to find the equation of the line of best fit, we need to determine or calculate the gradient of that line first. Then we'll combine it with the y-intercept, which we know is 14, and together we can then find the equation of the line in gradient intercept form, that is in the form y equals mx plus c. So to find the gradient or the slope of the line, we use the formula m equals change in y divided by change in x, otherwise known as rise over run. So going back to the line of best fit, notice that from left to right, it's going downhill so the gradient will be negative. Let's look at the change in y. That's the second coordinate, so the 14 and the 4. Think of it this way. We're starting at level 14, going down to level 4, which means we've gone down 10 levels. And looking at the change in x, that's the first coordinate, starting at 0, going across to 5, we've traveled 5 units across. So going back to the formula, m equals change in y divided by change in x, which is 4 minus 14 in brackets divided by 5 minus 0 in brackets. Now 4 minus 14 is negative 10, which we found earlier, and then divide that by 5 minus 0. So negative 10 divided by 5 gives us negative 2. Now the y-intercept is 14, which we saw earlier. Actually, just going back to the graph, that's it there. So combining the gradient and the y-intercept, we get the equation of the line of best fit is y equals negative 2x plus 14. Question 18. A table of future value interest factors for an annuity of $1 is shown. The prize in a lottery is an annuity of $5,000 a year for 10 years, invested at 4.5% per annum, compounding annually. What will be the value of the prize at the end of 10 years? We need to determine the correct interest factor from the table. Based on the information given, the prize money is invested at 4.5% per annum or per year, compounding annually or yearly, and that's over 10 years. So there are 10 compounding periods at 4.5% per period. So using the second row of the table and the third column, looking at where that row and that column intersect, we get this interest factor, 12.288. So if we're investing $1 per period for 10 periods at 4.5% per period, those 10 lots of $1 will have a future value of $12.288. But we want the future value of $5,000 invested per period over 10 periods at 4.5% per period. So 5,000, so that's $5,000 multiplied by that interest factor that we just found. So 5,000 times 12.288 gives us 61,440. Therefore, the prize value after 10 years is $61,440. Question 19. The activities and corresponding durations in days for a project are shown in the network diagram. Part A. Complete the table showing the immediate prerequisites for each activity. Indicate with a cross any activities without immediate prerequisites. Let's consider the immediate prerequisite or prerequisites for activity B. So looking at the network diagram, we find activity B and then consider the activity or activities that must be completed just before in order for activity B to commence. And from the network diagram, we can see that there are no immediate prerequisites for activity B. So in the table, we'll place a cross here in the row for activity B. Let's consider activity E. Now, on the network diagram, we can see that there are two immediate prerequisites. Activity C and activity D must be completed in order for activity E to commence. So in the table for activity E, under immediate prerequisites, we'll write C, D. Let's consider activity F in the network diagram. We can see that activity E must be completed before activity F can commence. So in the row for activity F, under immediate prerequisites, we'll write activity E. Part B. Find the critical path for this project and state the minimum duration for the project. Use forward and backward scanning to determine the earliest and latest start time for each activity. From that, we can determine the critical path and its minimum duration. Now, I've written the earliest and latest start time next to each activity, which are the two numbers in brackets, where the first number corresponds to the earliest start time and the second number corresponds to the latest start time. So starting from the left-handmost vertex here, which corresponds to the start of the project at day 0, the earliest start times for activities A and B is day 0. The earliest start time for activity C is day 3. The earliest start time for activity D is day 4. The earliest start time for activity E is day 9. The earliest start times for activities F and G is day 14. The earliest start time for activity H is day 21. Now, taking the higher of the two numbers, of 14 and 21, 21 plus 5 gives us 26, 14 plus 3 gives us 17. Now, the higher of the two numbers gives us the minimum duration of the project, which is 26 days. 21 plus 5 gives us 26, and that corresponds to the minimum duration of the critical path. Now, using backward scanning, the latest start time for activity A is at day 3. The latest start time for activity B is day 0. The latest start time for activity C is day 6. The latest start time for activity D is day 4. The latest start time for activity E is day 9. The latest start time for activity F is day 14. The latest start time for activity G is day 23. And the latest start time for activity H is day 21. Now, where the earliest start time and the latest start time are identical, that means there is no float time. In other words, those activities must start on time in order for the project to finish within the minimum duration of 26 days. So from that, we can see that B, D, E, F, and H are on the critical path. And I've stated that here in the answer. So using forward and backward scanning, the critical path is B, D, E, F, H with a minimum duration of 26 days. That is 4 plus 5 plus 5 plus 7 plus 5 equals 26. Part C. The duration of activity A is increased by 2. Does this affect the critical path for the project? Give a reason for your answer. Activity A takes 3 days to complete, and we saw earlier on that the earliest start time for activity A is at day 0 and the latest start time is at day 3, which means its float time is 3 days. Think of float time as spare time, time that we can either use to extend the duration of activity A. So rather than taking 3 days, it could take 4, 5, up to 6 days because we have 3 days of spare time, or we can delay the commencement of activity A if its duration was shorter than 6 days. So the float time for activity A is 3 days. Activity A can take 6 days to complete if started at day 0. Now, increasing activity A by 2 days will reduce the float time to 1 day. Like I said before, float time can be considered spare time. We can use some of that float time up. So increasing activity A by 2 days soaks up 2 days of the float time. This will reduce the float time to 1 day, which is not 0. We still have some float time or some spare capacity. And because the float time is not zero, so it's more than zero, this will not affect the critical path. Question 20. The graph of a quadratic function represented by the equation h equals t squared minus 8t plus 12 is shown. Part A. Find the values of t and h at the turning point of the graph. The horizontal coordinate of the turning point or vertex of the graph of a quadratic function lies halfway or midway between the two horizontal intercepts. In this case, the horizontal coordinate is represented by the variable t. So to find the horizontal coordinate or the t coordinate of this particular turning point, we find the average of 2 and 6. And we do that by adding them together and then dividing that by 2. So t is equal to open bracket 2 plus 6 close bracket. Now 2 plus 6 is equal to 8. We divide that by 2 and that equals 4. Now we need to find the value of h that corresponds to t equals 4. And we need to go back to the original equation. H is equal to t squared minus 8t plus 12. And we want the value of h when t is equal to 4. So by substitution, when t equals 4, h is equal to 4 squared minus 8 times 4 plus 12, and that equals negative 4. Therefore, t equals 4 and h equals negative 4 at the turning point. Part B. The graph shows h equals 12 when t equals 0. What is the other value of t for which h equals 12? The graph of a quadratic function is symmetrical about the horizontal coordinate of the turning point. In this case, the horizontal coordinate is represented by the variable t, and we found in part A that the value of t at the turning point is t equals 4. So this particular graph is symmetrical about t equals 4. So starting at t equals 4, if we move to the left-hand side 2 units or to the right-hand side 2 units, in other words, 4 minus 2 or 4 plus 2, we land at t equals 2 or t equals 6, and the value of h, which represents the height of that point above or below the horizontal axis, is the same. Now at t equals 2 and at t equals 6, h is equal to 0. The height of that point is 0, which means it lies on the horizontal axis directly. Starting at t equals 2, if we move another 2 units to the left, t is equal to 0, so 2 minus 2 gives us 0, but the value of h is equal to 12. So this particular point here is 12 units above the horizontal axis. So going the other way, from t equals 6, moving to the right another 2 units, so 6 plus 2 gives us 8, or t equals 8, the value of h here is identical to this value here. It's at the same height, so h is equal to 12. So to sum up, the graph is symmetrical about t equals 4. Therefore, the other value of t, where h is equal to 12, is t equals 8. Question 21. A house has a reverse cycle air conditioner which uses 2.5 kilowatts of power for cooling and 3.2 kilowatts of power for heating. The cost of electricity is 29 cents per kilowatt hour. Part A. Find the cost in dollars and cents of cooling the house for 6 hours. To find the electricity cost of using an appliance, we take the power used in kilowatts, multiply that by the time in hours that the appliance is in use for, and then we multiply that by the cost in dollars per kilowatt hour. Now the cost per kilowatt hour is quoted as 29 cents per kilowatt hour, and 29 cents in dollars is 0.29. So we'll keep that in mind for later on. Now we're asked to find the cost of cooling this house for 6 hours. And if we go back over the question, the reverse cycle air conditioner uses 2.5 kilowatts of power for cooling. So in the first part of the formula, the power used is 2.5 kilowatts, and we multiply that by 6 because the air conditioner is in use for 6 hours. And then we multiply that by 0.29 because that's the cost in dollars per kilowatt hour, and we get 4.35. Therefore, the cost to cool the house is $4.35. Part B. The cost of operating the air conditioner to heat the house during winter last year was $640. There are 92 days in winter. Find the number of hours to one decimal place that the air conditioner was used on average per day. Looking at the question in more detail, we're told that the air conditioner is heating the house rather than cooling the house. If you go back to the preamble, that's this paragraph here, it's given that the air conditioner uses 2.5 kilowatts of power for cooling and 3.2 kilowatts of power for heating. So we need to keep that in mind, that the power used is 3.2 kilowatts, not 2.5 kilowatts. Now this air conditioner is used during winter, and there are 92 days in winter, and the total electricity cost is $640. And we want to know the number of hours, correct to one decimal place, that the air conditioner was used for on average per day. So there's two basic steps. In the first step, we need to find the total number of hours that the air conditioner was in use for during the entirety of winter. So that's over the 92 days. And then we divide that by 92 to get the average usage, or the average time usage per day during those winter days. So we need to solve the equation 640 equals 3.2 times h times 0.29. And we're solving for h, which represents the number of hours that the air conditioner was in use for. Now $640 is the electricity cost, 3.2 kilowatts is the power used, and 0.29 is $0.29 per kilowatt hour, and that's the cost per kilowatt hour. We want to solve for h by rearranging this equation, noting that h is being multiplied by 3.2 and multiplied by 0.29. We can reverse multiplication by division, and we can make h the subject all in one step. So h is equal to 640 divided by 3.2 divided by 0.29, and we get 689.6551724 hours. We'll do the rounding right at the very end. So this is the total number of hours that the air conditioner was in use for during the 92 days in winter. So dividing that by 92, we get 7.496 and so on, and we need to round this value to one decimal place, and that rounds to 7.5. Therefore, the air conditioner was used around 7.5 hours on average per day during winter. Question 22. A network of pipes with one cut is shown. The number on each edge gives the capacity of that pipe in litres per minute. Part A. What is the capacity of the cut shown? Of all the edges that this cut passes through, only 3 edges need to be considered when calculating the capacity of this particular cut. And they are edges BD, EG, and CF. Now, edge BD is an inflow to vertex D, and by cutting BD, that automatically cuts off ED and DG. So we don't need to consider ED as part of the cut. We need to cut off edge CF because that's an inflow to vertex F, which automatically cuts off EF and FG. This leaves us vertex E. Now, since ED is automatically cut off and EF is automatically cut off because we've cut off BD and CF, there's only one more path left from A to G. That's A to C to E and then to G. Now, the only edge that can be cut off that counts towards the capacity of this cut would be EG. So I've circled the capacities of those edges and we add those capacities together to give us the capacity of the cut. So 26 plus 24 plus 12 equals 62. Therefore, the capacity of this cut is 62 litres per minute. Part B. The diagram shows a possible flow for this network of pipes. Part 1. What is the value of X? Give a reason for your answer. Consider vertex C. The inflow of C must equal the outflow of C. Now, the inflow of C is X and the outflows are 5, 13 and 12. So X is equal to 5 plus 13 plus 12, which gives us 30. Therefore, X is equal to 30. Part 2. Which of the pipes in the flow are at full capacity? The diagram in Part B shows actual flow through the pipes that make up this network. So for example, pipe AB is shown to be flowing 18 litres per minute. Now the question is pipe AB flowing at its maximum capacity? In other words, have we saturated that pipe? So if we look at the diagram from Part A, which I've shown here for reference, pipe AB has a maximum capacity of 24 litres per minute. So clearly, pipe AB is not flowing at maximum capacity. Now there are 4 edges that are flowing at maximum capacity where the flow through the pipe is equal to the rated capacity of that pipe as indicated in Part A. And they are edges DE, DG, CF and FG. And I've written that answer here. So comparing diagrams from parts A and B, DE, DG, CF and FG are at full capacity. Part 3. The maximum flow for this network is 50 litres per minute. Which path of pipes could have an increase in flow of 2 litres per minute to achieve the maximum flow? We can increase the flow through the pipes that make up path ACEG by 2, since those pipes are not flowing at their maximum capacity. So if we go back to the diagram in Part B and then compare it to the diagram in Part A, we can see that AC is flowing 30 litres per minute, but the capacity of that pipe is 35 litres per minute. So we have a capacity or a spare capacity of 5 litres per minute. CE is flowing 13 litres per minute, but its capacity is 17 litres per minute. So we can increase that by 4. And pipe EG is currently flowing 22 litres per minute, but its capacity is 24 litres per minute. And that is why we can increase ACEG by 2 to give us a flow of 50 litres per minute. Question 23. Company A and Company B both issue an annual dividend per share as shown in the table. Based on the dividend yield, which company would be better to invest in? Think of it like this. If you invest in Company A, you have to pay $25.43 to earn $4.92 per year, assuming that the dividend paid stays the same each year. Now, if we invest in Company B, we have to pay $2.13 in order to earn 45 cents each year. So let's compare the dividend paid with respect to the current share price of each company. So let's consider Company A. Now, Company A pays a dividend of $4.92 and the share price is $25.43. So we want to work out the dividend as a percentage of the share price, also called the percentage dividend yield. So $4.92 divided by $25.43, multiplying that by 100 to convert the result into a percentage, we get around 19.3%. Let's calculate the dividend yield for Company B. Now, Company B pays 45 cents, which is $0.45. Dividing that by its share price of $2.13 and then multiplying that by 100, we get around 21.1%. So clearly, Company B outperforms Company A when it comes to dividends. So Company B has a higher dividend yield, so it's a better investment than Company A. Question 24. The population of snails in a garden is approximately 90. One night, Bobby collected 18 snails from the garden. He tagged each snail and released it back into the garden. The next night, 20 snails were captured from the garden. Approximately how many of the snails in the second sample are expected to have a tag? We know that the population of snails in a garden is approximately 90. Now, Bobby collects 18 of those snails from the garden and then tags them. So the fraction of the population that are tagged is worked out by taking the number of tagged snails and dividing that by the population of snails in the garden. So 18 over 90, which simplifies to 1 over 5. What this means is 1/5 of the snails are tagged. Which stands to reason that if we take a sample of those snails at some later time, we expect around 1/5 of that sample to also be tagged. So the number in the sample expected to be tagged is 1/5 of 20. That's because 20 snails later on were captured from the garden. So 1/5 of 20 is 1/5 times 20, so of means times, and 1/5 of 20 is 4 snails. Question 25. In a research study, participants were asked to record the number of minutes they spent watching television and the number of minutes they spent exercising each day over a period of 3 months. The averages for each participant were recorded and graphed. Part A. Describe the bivariate dataset in terms of its form and direction. In terms of form, this bivariate dataset could either be linear or non-linear. Now, linear means a straight line relationship, and looking at the scatter plot, we can see that the general trend follows a straight line. So the form is linear. Now, in terms of direction, as the x values are getting larger, the question is, are the y values getting larger, smaller, or neither? But we can see that as the x values get larger, the general position or the vertical position of the points gets smaller or gets closer to the x-axis. So if we were to visualize a straight line, we can see that the straight line will have a negative gradient. So the direction is negative, and I've stated the answers here. So the form is linear or straight line, and direction is negative. Y gets smaller as x gets larger. The equation of the least squares regression line for this dataset is y equals 64.3 minus 0.7x. Part B. Interpret the values of the slope and y-intercept of the regression line in the context of this dataset. To help make the question easier to answer, we can express the equation of the least squares regression line in the form y equals mx plus c in that order. So at the moment, it's in the form y equals c plus mx. Now, the m happens to be negative, which is why it's negative 0.7x. So writing it in the form y equals mx plus c, where m is the gradient and c is the y-intercept, we get y is equal to negative 0.7x plus 64.3. So the gradient or slope of this least squares regression line is negative 0.7, and the y-intercept, which represents the point where the line crosses the y-axis, so that's where x is equal to 0, is 64.3. Now we saw in part A that the direction of the bivariate dataset is negative. And this corresponds to our negative gradient here of negative 0.7. So interpreting the gradient or the slope of negative 0.7, what this means is for every 1 minute increase in watching television, the time spent exercising is reduced by 0.7 minutes. And we saw earlier on in part A that as the x values get larger, the y values get smaller. So as the x values get larger by 1 minute, the y values get smaller by 0.7 minutes. Interpreting the y-intercept, now the y-intercept is a point that occurs when x is equal to 0. Now x represents the amount of time watching television. So when x is equal to 0, that means someone is not watching any TV at all. So someone who does not watch any television is expected to spend 64.3 minutes exercising. Part C. Joe spends an average of 42 minutes per day watching television. Use the equation of the regression line to determine how many minutes on average Joe is expected to exercise each day. Let x equal 42 and substitute that value for x in the equation of the least squares regression line, which is y equals 64.3 minus 0.7 times x. So y is equal to 64.3 minus 0.7 times 42, which equals 34.9. Therefore, Joe is expected to exercise 34.9 minutes each day. Part D. Explain why it is not appropriate to extrapolate the regression line to predict the average number of minutes of exercise per day for someone who watches an average of 2 hours of television per day. 2 hours of watching television is equal to 120 minutes of watching television. Now going back to the scatter plot, the x-axis represents the amount of time watching television. And we can see that the values are from 0 to 60. There are no points on the scatter plot which correspond to values of x greater than 60. So it's outside the range of data on this scatter plot. And I've written that here. So it's outside the range of data on the scatter plot, hence extrapolation will be unreliable. Also, if we were to let x equal 120 and substituting x equals 120 into the least squares regression line equation, we get y is equal to 64.3 minus 0.7 times 120, which is equal to negative 19.7 minutes of exercising, which is clearly invalid. Question 26. A toy has a curved surface on the top which has been shaded as shown. The toy has a uniform cross-section and a rectangular base. Part A. Use two applications of the trapezoidal rule to find an approximate area for the cross-section of the toy. To use one application of the trapezoidal rule, we apply the formula area A is approximately equal to h over 2 times a plus b in brackets, or we could write it as area A is approximately equal to half times h times a plus b in brackets, where A and B represent the lengths or the heights of the vertical sides, and h represents the gap or the distance between them. Now the question is asking us to use two applications of the trapezoidal rule. This means using this formula twice to find an approximate area of the cross-section of the toy. So we need to find the value of h first, and to do that we take the length of this edge here, 10.2 centimeters, and we divide it by 2. These are our two applications, application 1 and application 2. And in each case, or in each application, the value of h is the same. Now we divide it by 2 because this gap is identical to this gap because of this dash here and here. This means 10.2 is divided exactly in half. So 10.2 divided by 2 gives us 5.1 centimeters. And that's what we substitute for h in the formula. Now to apply the two applications of the trapezoidal rule, we substitute 5.1 for h. So here is the first application. Area is approximately equal to half times 5.1 times 6.0 plus 3.8 in brackets. So that gives us an approximate area for this region here, plus half times 5.1 times 3.8 plus 0 in brackets, which gives us an approximate area for this region here. Then we add the two approximations together. So half times 5.1 times 6.0 plus 3.8 in brackets gives us 24.99, and half times 5.1 times 3.8 plus 0 in brackets gives us 9.69. So adding those together, we get 34.68. Therefore, the area of the cross section is around 34.68 square centimeters. Part B. The total surface area of the plastic toy is 1,300 square centimeters. What is the approximate area of the curved surface? Looking at the diagram, we can see that the toy is a three-dimensional object made up of 5 surfaces. We have the curved surface, the front surface, the back surface, the left surface, and the base surface. In the preamble of the question, it is stated that the toy has a uniform cross-section and a rectangular base. Now, I've underlined uniform cross-section as a point of importance because that makes this 3D object a prism, which implies that the front surface is identical in shape to the back surface. Uniform cross-section means the shape is identical all the way through, as if this was a tunnel and you were looking around it would appear identical as you walk from front to back. Now it's given that the total surface area of the plastic toy is 1,300 square centimeters, and we want to find the approximate area of the curved surface. So if we add up all 5 of these surfaces, we get 1,300 square centimeters. 4 of them we can find, 1 is unknown, which is the curved surface. So we can form an equation. 1,300, which is the total surface area, is approximately equal to the sum of the 5 areas that make up this three-dimensional object. 34.68 times 2, if we go back to the diagram, 34.68 is the approximate area of the cross-section. And because the front and the back are identical, we multiply 34.68 by 2. Then we add on to that 6.0 times 40.0, which represents the area of the left surface, which is this rectangle here. And then we add on to that the area of the rectangular base, which is 10.2 times 40.0. Finally, we add on the curved surface, and this gives us 1,300. So adding the known values together, 34.68 times 2 plus 6.0 times 40.0 plus 10.2 times 40.0 gives us 717.36. So that represents the area of the known surfaces. They're the 4 surfaces that we know the areas of. So 1,300 total surface area is approximately equal to 717.36 plus the curved surface. So if we subtract 717.36 from 1,300, we can estimate the area of the curved surface. So that's 1,300 minus 717.36, which gives us approximately 582.64 square centimeters. Part C. The measurements shown on the diagram are given to the nearest millimeter. What is the percentage error of the measurement of 10.2 centimeters? Give your answer correct to 3 significant figures. It is stated that the measurements shown on the diagram are given to the nearest millimeter, which is the same as saying to the nearest 0.1 centimeters. This implies that the precision or the accuracy of those measurements is 0.1 centimeters. Now to find the absolute error, we divide the precision by 2. So 0.1 divided by 2 is equal to 0.05. Now the percentage error gives us the absolute error relative to the measurement in question, which is 10.2 centimeters. In other words, how big is this absolute error compared to the measurement of 10.2 centimeters? And we want that as a percentage. So we find the percentage error by taking the absolute error, so 0.05, dividing that by the measurement in question, which is 10.2 centimeters, and then we multiply that by 100 to convert our result into a percentage. And we get 0.49016 and so on percent, which is equal to 0.490%, correct to 3 significant figures. Question 27. A credit card has an interest-free period of 45 days from and including the date of purchase. Interest is charged on purchases made, compounding daily at a rate of 13.74% per annum from and including the day following the interest-free period. Concert tickets were purchased for a total of $392 using this credit card. Full payment was made on the 68th day from the date of purchase. There were no other purchases on this credit card. What was the total interest charged when the account was paid in full? The first thing we need to work out is the number of days that interest applies on this $392 purchase. Going back to the question, a credit card has an interest-free period of 45 days from and including the date of purchase. So the first 45 days, zero interest applies. Now, after the 45th day, so that's indicated by the word following, that's when interest begins to accrue. Now, we're also given that full payment was made on the 68th day from the date of purchase. So the number of days that interest applies is 68 because the total amount was repaid on the 68th day, but the first 45 days, zero interest applies. So 68 minus 45 gives us 23 days. Now, to work out the total repaid, we use the compound interest formula, noting that we need the interest rate per day, not the interest rate per annum. And we know this because of these two words here, compounding daily, not compounding annually. So using the compound interest formula, the total amount repaid is equal to the principal, so that's the purchase price of $392, multiplied by, now open bracket, 1 plus the interest rate per annum, so that's 13.74% per year, and there are 365 days in a year. I get that there's a leap year, but we generally accept that there's 365 days in a year when working out financial calculations. So dividing 13.74% by 365, close brackets, and then we raise this to the number of days that interest applies for, which is 23 days. And we get 395.40805 and so on. But it's a dollar amount, so we need to round it correct to the nearest cent, so 2 decimal places. So that's $395.41. So the interest charged, which is what the question is asking us, is the difference between the purchase price, so $392, and the total amount repaid, which is $395.41. So subtracting one from the other, the bigger amount comes first, of course. 395.41 minus 392 gives us $3.41, which is the interest charged on this purchase. Question 28. The heights of students in a class were recorded. The results for this class are displayed in the cumulative frequency graph shown. The shortest student in this class is 130 centimeters and the tallest student is 180 centimeters. Construct a box plot for this class in the space below. Before we can draw the box plot, we need to work out the 5-number summary. That is, we need the minimum score, the first quartile Q1, the median, the third quartile Q3, and the maximum score. Now, the minimum score and the maximum score is simple to work out. In fact, it's given to us. The shortest student in this class is 130 centimeters, and the tallest student is 180 centimeters. So the minimum score is 130, and the maximum score is 180. So we just need to work out the first quartile Q1, the median, and the third quartile Q3. So referring to the cumulative frequency graph, we can see that there are 30 students that have been surveyed. In other words, there are 30 scores. And because we're referring to the cumulative frequency graph rather than the individual scores in a list, the median is the point that is halfway between 0 and 30, which is 15. So this is our 15th score here. So I've drawn a horizontal line across, and it lands on the ogive here, so exactly halfway between 135 and 145. So the median is the midway between 135 and 145, which is 140. So to work out Q1, that's the point that is halfway between 0 and 15, which is at 7.5. Drawing a horizontal line across until it strikes the ogive and then drawing a vertical line down, we can see that Q1 is 135. And we repeat the same thing for Q3. So between 20 and 25, so that's at 22.5. So that's halfway between 15 and 30. Drawing a horizontal line across, we strike the ogive here, exactly between the two columns. Going down, it's halfway between 155 and 165, and that's 160. So Q3 is 160. So here is our completed 5-number summary. Minimum is 130, Q1 is 135, the median is 140, Q3 is 160, and the maximum is 180. Now we can proceed to draw the box plot. Using the number line provided, we can draw the box plot to scale. So the first point is the minimum score, which is at 130. The second point, so that's the start of the box part of the box plot, that's Q1, the first quartile. Now the vertical line that's inside the box represents the median, so that's at 140. This point here, so that's the other end of the box, is Q3, or the third quartile, which is located at 160. And the last point is the maximum score at 180. Question 29. A bag contains 7 blue lollies and 9 yellow lollies. One lolly is selected at random and eaten. A second lolly is then selected from the remaining lollies in the bag. Find the probability that the 2 lollies selected are the same color. The question states that one lolly is selected at random and eaten. So this implies selection without replacement. Initially, there are 16 lollies in the bag. 7 blue lollies plus 9 yellow lollies. So the first selection is a probability out of 16. In the second selection, there is one less lolly in the bag because it's been eaten, so it's going to be out of 15. Now we want the probability that the 2 lollies selected are the same color. So we can either have a blue lolly followed by a blue lolly or a yellow lolly followed by another yellow lolly. So let's consider the probability of a blue lolly followed by a blue lolly. So initially there are 7 blue lollies out of 16. So in the first draw, the probability of a blue lolly is 7 over 16. So one blue lolly has been taken out of the bag. So there are 6 blue lollies left out of a total of 15. So in the second draw, the probability of choosing a blue lolly is 6 over 15. So the probability of selecting 2 blue lollies is found by multiplying these two probabilities. So 7 over 16 times 6 over 15 is 7 over 40. Let's consider the case where we draw a yellow lolly followed by another yellow lolly. And that'll be 9 over 16 times 8 over 15, based on the same logic as choosing a blue lolly followed by another blue lolly, except we have 9 yellow lollies to begin with. We eat one, we now have 8 yellow lollies, and instead of being out of 16, it is now out of 15 in the second draw. Multiplying these two probabilities together, so 9 over 16 times 8 over 15, gives us the probability of choosing 2 yellow lollies, and that's 3 over 10. So to find the probability of choosing 2 lollies of the same color, we add these two probabilities together. 7 over 40 plus 3 over 10, and that gives us 19 over 40, or 47.5%. Question 30. It costs $465 to register a passenger car and $350 to register a motorcycle. Let P equal the number of passenger cars and B equal the number of motorcycles. Write two linear equations that represent the relationships below. There are 11 times as many passenger cars as motorcycles, and the total registration fees for passenger cars and motorcycles is $494 million. Let's look at the first dot point. There are 11 times as many passenger cars as motorcycles. This means for each motorcycle, there are 11 cars. So we multiply the number of motorcycles by 11. Now B represents the number of motorcycles. So 11 times B is equal to P, where P represents the number of passenger cars. Rewriting this equation, so P is the subject, and we don't have to show the time symbol. We write it as P is equal to 11B. Let's look at the second dot point. The total registration fees for passenger cars and motorcycles is $494 million. Now, 494 million can be written as 494 followed by 6 zeros. That's 494 million. Now, recall, so going back to the start of the question, that it costs $465 to register a passenger car and $350 to register a motorcycle. So for every passenger car, so for every P, we have to multiply that by $465. And for every B, which represents the number of motorcycles, we've got to multiply that by 350. So 465P or times P plus 350 times B is equal to 494 million. So to summarize, therefore, the two linear equations are P is equal to 11B and 465P plus 350B is equal to 494 million. Question 31. The table shows the income tax rate for Australian residents for the 2024-2025 financial year. At the end of the 2024-2025 financial year, Alex's tax payable was $47,420, excluding the Medicare levy. What was Alex's taxable income? We are told that Alex's tax payable was $47,420. Referring to the tax table, that's greater than $31,288 but less than $51,638. Which means Alex's taxable income must be in this range here, between $135,001 and $190,000. So in order to work out Alex's taxable income, we can use some algebra. Form an equation and then solve that equation for the taxable income. So I'm going to let X equal Alex's taxable income. And now that we know which row of the tax table to reference, we just follow the rule. So whatever Alex's taxable income is, which in this case is represented by the variable X, we know that he must have paid $31,288 plus 37 cents for each dollar over $135,000. So in other words, 31,288 plus 0.37 times X minus 135,000 in brackets is equal to $47,420. So this step here is critical in forming the correct equation, and then we proceed to solve it. So we're just following the rule from the tax table. Now 37 cents for each dollar is interpreted as 37% or 0.37 of the difference between the taxable income and $135,000, which is represented in this expression here inside the brackets. So Alex's taxable income minus $135,000, and that's the difference between Alex's taxable income and $135,000. So solving this equation, we subtract 31,288 from 47,420, and we can do that by moving this value over to the other side. It becomes a minus. And so on the right-hand side, we have $16,132. And on the left-hand side, we have 0.37 times x minus 135,000 in brackets. The next step is to divide both sides of this equation by 0.37. And we get x minus 135,000 on the left-hand side, and that equals 43,600 on the right-hand side. The final step is to add 135,000 to both sides of the equation. Or another way to put it, we can take this minus 135,000 and move it to the other side, and it becomes plus. And we get x is equal to 178,600. Therefore, Alex's taxable income is $178,600. Question 32. Solid spheres are placed inside a square-based pyramid as shown. The base of the pyramid has side lengths of 14 centimeters. The height of the pyramid is h centimeters. The radius of each sphere is 1.5 centimeters. The amount of empty space remaining inside the pyramid after 30 spheres have been placed inside the pyramid is 634 cubic centimeters. What is the height, h, of the pyramid? Give your answer correct to the nearest centimeter. This question involves the volume of spheres and pyramids. So to find the volume of a sphere, we use the formula volume V is equal to 4 times pi times the radius cubed divided by 3. And to find the volume of a pyramid, we use this formula, the volume V is equal to the area of the base multiplied by the perpendicular height, and we divide that by 3. So let's go through the solution for this question. The first thing we need to find is the volume of 30 spheres. And that's 4 times pi times the radius cubed. So the radius of one sphere is 1.5 centimeters. So 1.5 cubed divided by 3 in brackets. And that gives us the volume of one sphere. Then we multiply that by 30. And we get 424.1150082 cubic centimeters. We'll do all the rounding at the very end. The next thing we need to know is the volume of the pyramid. And the volume of a pyramid is given by the formula area of the base multiplied by the height divided by 3. In this case, we don't know what the height is, so we'll just leave it as h. That's what we want to find at the end. Now the area of the base is 14 times 14 or 14 squared multiplied by h divided by 3 is equal to the volume of the 30 spheres that we found earlier plus the empty space, which is 634 cubic centimeters, which was stated here. So on the right hand side, if we add both of those values together, we get 1058.115008 cubic centimeters, and that's equal to 196 times h divided by 3. Now 196 is 14 times 14 or 14 squared. So multiplying both sides of this equation by 3 to undo this division by 3 on the left-hand side, we get 196 times h is equal to 3,174.345024. And then dividing both sides of this equation by 196 to isolate h, we get h is equal to 16.19563788 and so on. But the question is asking us to give our answer for h correct to the nearest centimetre. So therefore the height h of the pyramid is 16 centimetres, correct to the nearest centimetre. Question 33. A used car has a sale price of $24,200. In addition to the sale price, the following costs are charged. Transfer of registration, $50. Stamp duty, which is calculated at $3 for every $100 or part thereof of the sale price. Cat borrows the total amount to be paid for the car, including transfer of registration and stamp duty. Simple interest at the rate of 6.8% per annum is charged on the loan. The loan is to be repaid in equal monthly repayments over 3 years. Calculate Cat's monthly repayment. The first thing we need to work out is the total amount borrowed, which consists of adding the sale price of the car, which is $24,200, plus the transfer of registration, which is $50, and that's stated here, plus the stamp duty. Now to work out the stamp duty, we follow the instructions on the second dot point here. Stamp duty is calculated at $3 for every $100 or part thereof of the sale price. So taking this value here, $24,200, we want to work out how many lots of $100 is equal to $24,200. So dividing this value by 100, $24,200 can be written as 242 lots of, or times, $100. And for every $100, the stamp duty is $3. So there are 242 lots of $100, so that's why the stamp duty here is 242 times $3. So adding these three values up, we get $24,976. The next thing we need to work out is the interest charged on this simple interest loan. So using the formula I equals P times R times N. Now P, which is the principal, is this value here, 24,976. Now the simple interest is charged at a rate of 6.8% per annum, and it's over 3 years, and that's stated here. So the interest charged, I, is equal to the principal, 24,976, times 6.8%, or 6.8 over 100, times 3. And that equals 5,095.104, which rounds to $5,095.10, correct to the nearest cent. The next thing we need to work out is the total value of the repayments. So we take the principal, so that's the amount borrowed, which is $24,976, and then we add on to that the interest that is charged, which is this value here, so $5,095.10, and we get $30,071.10. So lastly, to work out the monthly repayment, we take the total value of the repayments, and it's over 3 years, so we divide that by 3, But because it's monthly, we divide that again by 12 since there are 12 months in a year. And we get 835.3083 and so on, which rounds to $835.31 or $835.31. Therefore, the monthly repayment is $835.31, correct to the nearest cent. Question 34. The table shows future value interest factors for an annuity of $1. Lynn invests a lump sum of $21,000 for 7 years at an interest rate of 6% per annum, compounding monthly. Yemi wants to achieve the same future value as Lynn by using an annuity. Yemi plans to deposit a fixed amount into an investment account at the end of each month for 7 years. The investment account pays 6% per annum, compounding monthly. Using the table provided, determine how much Yemi needs to deposit each month. We'll start by working out the future value of Lynn's investment. Now, Lynn invests a lump sum of $21,000 at 6% per annum, compounded monthly, for a period of 7 years. So using the compound interest formula, or the future value formula, that is, future value is equal to the present value, or the principal, times 1 plus r in brackets to the power of n. Now the r is 0.06 divided by 12. Now 0.06 is 6% as a decimal, and we divide that by 12 because it's 6% per annum or per year, but it's compounded monthly, and there are 12 months in a year. So the compound interest rate per month is 0.06 divided by 12. But we need to raise that to the power of the total number of compounding periods over 7 years. There are 12 compounding periods per year, and we multiply that by 7, and that gives us 84. So evaluating this expression, 21,000 times 1 plus 0.06 divided by 12 in brackets to the power of 7 times 12, or to the power of 84, we get $31,927.76, correct to the nearest cent. Now let's consider Yemi's investment. We know the future value of Yemi's investment must equal the future value of Lynn's investment, which is $31,927.76. But rather than investing all that money up front as a lump sum, Yemi will be using an annuity. So there'll be a monthly deposit, and we need to work out what the value of that monthly deposit is so that the future value of Yemi's investment is equal to this value here. So we need to find the correct interest factor from the table. So we need to find out the value of R, which is the rate of compound interest per period. Now we know it's 0.06, so that's 6% per annum. Dividing that by 12, and we get R is equal to 0.005. So that gives us which column to select from the table. But in order to work out which row, we need to work out the total number of compounding periods. Now we've already worked that out. That's 7 times 12, and that gives us 84. So going back to the table, we select the column with the heading of 0.005 and the row which has a heading of 84, and where the column and the row intersect, this is our interest factor. So the interest factor is 104.07393. So to work out the future value, we take the monthly deposit and we multiply that by the interest factor. Now we know what the future value is. It's $31,927.76. And that's equal to the monthly deposit multiplied by the interest factor that we just found. So we form a simple equation, and we need to make the monthly deposit the subject. And we do that by dividing 31,927.76 by 104.07393. And I've written that equation here, rearranged, so that the monthly deposit is the subject. And that evaluates to $306.78. Question 35. The triangle PTA is shown. The length of PA is 75 meters and the length of PT is 51 meters. The angle of depression from T to A is 36 degrees and the angle PTA is obtuse. Find the length of TA. Give your answer correct to 2 decimal places. The question states that the angle of depression from T to A is 36 degrees, and that's not shown on the diagram. So we'll start by indicating this angle of depression by drawing a dashed line from point T to the right-hand side parallel to PA. And I've indicated the angle of depression here. So that's the angle looking down from this dashed line toward point A. Now the angle of elevation from A to T, so that's the angle looking up, is equal to the angle of depression. So angle TAP is equal to 36 degrees. Now let's look at triangle PTA. So that's this large non-right angled triangle. And we have 2 known sides. So we know side PT, that's 51 meters, and side PA, which is 75 meters. And we also know angle TAP or PAT, which is 36 degrees. So we have a known side angle pair, which means we can use the sine rule to find the size of the angle that's opposite the other known side. So that's side PA. So the angle that we're referring to is angle PTA. So using the sine rule, we have sine of angle PTA divided by 75 is equal to sine 36 degrees divided by 51. Multiplying both sides of the equation by 75 to isolate sine of angle PTA, we get sine of angle PTA is equal to sine 36 degrees divided by 51 times 75. Evaluating the right-hand side, we get 0.86439000769 from the calculator. We'll do all the rounding at the very end. Next, to find angle PTA, we take the inverse sine of this value here. So angle PTA is equal to inverse sine of 0.86439 and so on, and that evaluates to 59.81313282 degrees. And that's the acute angle. But we're told that angle PTA is obtuse. So to find the obtuse angle, we take the acute angle and subtract it from 180 degrees. And we get 120.1868672 degrees. Recall that the angle sum of a triangle is 180 degrees. So we just found angle PTA, which is the obtuse angle, which is just over 120 degrees. We know this angle here, which is 36 degrees, which means we can work out angle TPA by subtracting 120 degrees and 36 degrees from 180 degrees. So angle TPA is equal to 180 degrees minus 36 degrees minus 120.1868672 degrees, and that equals 23.8131328 degrees. We can apply the sine rule one more time to find the length of side TA. So going back to the diagram, we want to find the length of TA. We know this angle here, so that's a side angle pair where the angle is known but the side is unknown. And we can use this side angle pair here, the original side angle pair that we used earlier on, which is 51 meters opposite the 36 degree angle here. So TA divided by sine of 23.813 and so on degrees is equal to 51 divided by sine of 36 degrees. Moving this divide sine 23.813 on the left-hand side over to the right-hand side, and we do that by multiplication, we get TA is equal to 51 divided by sine 36 degrees times sine of 23.813 and so on degrees, which equals 35.03236 and so on. But we need to round that correct to 2 decimal places. So we get TA is equal to 35.03 meters, correct to 2 decimal places. Question 36. The graph shows the salvage value of a car over 5 years. The salvage values are based on the declining balance method. By what amount will the car's value depreciate during the 10th year? Looking at the graph, and in particular, looking at the value of the car at year 0 and year 1. Now at year 0, the price of the car was $55,000. So that's the original purchase price of the car. Now at year 1, or 1 year after the car was purchased, the value of the car is $44,000. So clearly, the car has lost or depreciated in value by $11,000. And I've stated that here. The car loses $11,000 in the first year. Now the next step is to work this out as a percentage loss or a percentage depreciation. And that's found by this formula. 11,000 divided by 55,000, so it's a percentage loss relative to the purchase price of the car. And then we multiply that by 100 to give us the answer as a percentage, and we get 20%. So the car is losing 20% year on year. The next step is to find the salvage value of the car in the 9th year, because the question is asking for the car's value, or at least the depreciation of the car's value during the 10th year. So we need to find the salvage value of the car in the 9th year, the salvage value of the car in the 10th year, and then find the difference between the two. So using the declining balance formula, the salvage value of the car in the 9th year is 55,000 times 1 minus 20%, or 1 minus 0.2, in brackets to the power of 9, and that equals $7,381.98. So in other words, if the car was sold at the end of the 9th year, this would be the value of the car. Now to work out the salvage value of the car in the 10th year, we use the same declining balance formula. 55,000 times 1 minus 20%, or 1 minus 0.2, in brackets to the power of 10, because it's 10 years, and we get $5,905.58. So to find the value lost in the 10th year, we take this value here, and then we subtract from that this value here. So the difference between the 9th year and the 10th year. So the value lost in the 10th year is 7,381.98 minus 5,905.58, and we get $1,476.40. Question 37. The diagram shows a park consisting of two equilateral triangles. The shaded triangle is a grassed section. All measurements on the diagram are in meters. How long will it take to mow the grassed section if it takes 5 minutes to mow 20 square meters? Give your answer to the nearest minute. There are a number of ways to work out the area of the grassed section, which is in the shape of an equilateral triangle. The strategy I'm going to use here is to work out the area of the large equilateral triangle and then take away from that the areas of these three small ungrassed areas which are in the shape of scalene triangles. Now recall that in an equilateral triangle, all angles are equal in size and add up to 180 degrees. So each of these angles are 60 degrees. Now we're given the side lengths of the large equilateral triangle. So we have 9 meters plus 3 meters, which gives us 12 meters in total. So to work out the area of the large equilateral triangle, we use the area rule of a triangle, which is half AB sine C. So that's half times 12 times 12 times sine of 60 degrees, and that's equal to 62.35382907 square meters. We'll do all the rounding at the very end to maintain as much accuracy as possible. Next, we find the area of triangle ABC, which I've marked here. So we have side lengths of 9 meters and 3 meters, and the angle in between, or the included angle, is 60 degrees. So using the area rule once again, the area of triangle ABC is half times 9 times 3 times sine of 60 degrees, which is equal to 11.69134295 square meters. Now, these three triangles are identical in area. So to find the area of the grassed section, we take away from the large equilateral triangle 3 times the small ungrassed triangular areas. So the area of the grass section is 62.35382907 minus 3 times 11.69134295, which equals 27.27980022 square meters. Finally, to find the time to mow the grassed section, we use the unitary method. Now we know that it takes 5 minutes to mow 20 square meters. So to find the number of minutes it takes to mow 1 square meter, we take 5, we divide that by 20, but then we multiply that by the total number of square meters that we need to mow, which is 27.27980022, which equals 6.819 minutes. Now rounding that correct to the nearest minute, it takes 7 minutes to mow the grassed section, correct to the nearest minute. Question 38. A car's fuel efficiency is 30 miles per US gallon. 1 US gallon equals 3.8 litres, correct to two significant figures, and 1 mile equals 1.6 kilometres, correct to two significant figures. Calculate the car's fuel efficiency in litres per 100 kilometres, correct to one decimal place. We'll begin by converting miles and US gallons into kilometres and litres. So using the conversion table, 30 miles is equal to 30 times 1.6 kilometres, because it's stated here that 1 mile is equal to 1.6 kilometres, and that equals to 48 kilometres. Now 1 US gallon, according to the table, is 3.8 litres. So 30 miles per US gallon can be written in terms of kilometers and liters as 48 kilometers per 3.8 liters. Now we can write this rate in reverse. If it's 48 kilometers per 3.8 liters, we can also say that it takes 3.8 liters to travel 48 kilometers. So we say 3.8 liters per 48 kilometers of distance traveled. But we want the number of liters per 100 kilometers of distance traveled. So using the unitary method, 3.8 divided by 48 gives us the number of liters it takes to travel 1 kilometer, and then we multiply that by 100 and we get 7.9166 and so on liters. So writing our answer correct to one decimal place, 30 miles per US gallon is equivalent to 7.9 liters per 100 kilometers. Question 39. After a dose of a medication, the amount of the medication remaining in a person can be modeled by the equation y equals k times a to the power of x, where x is the number of hours after taking the dose, and y is the amount remaining in milligrams, mg. The graph shows the amount of the medication remaining in a person after x hours. 2 points are also shown on the graph. Using the information provided, find the amount of medication that remains in a person when x equals 4. An equation of this form, y equals k times a to the power of x, is an exponential equation. And looking at the shape of the graph, we can see that the graph is decreasing from left to right. This means the base a must be a value greater than 0 but less than 1. And the value of k represents the y-intercept. Now in this case, the y-intercept is 15, and that occurs when x is equal to 0. Now x represents the number of hours after taking a dose of medication, and y represents the amount of medication remaining in a person in milligrams. So when x is equal to 0, this means the amount of medication remaining, the initial amount of medication, is 15 milligrams. That means k is equal to 15. And I've stated that here in the solution. The initial amount of medication remaining occurs when x is equal to 0, which means k is equal to 15, and we can rewrite the equation, now that we know the value of k, as y equals 15 times a to the power of x. Now we need to work out the value of the base a, and we need another point in order to do so. And we're given another point, which is this point here. When x is equal to 2, y is equal to 9. And we can substitute those two values for x and y into the equation, y equals 15 times a to the power of x, and then solve for a. So when x is equal to 2, y is equal to 9. So 9 is equal to 15 times a to the power of 2, or a squared. Rearranging this equation to isolate a squared, we get a squared is equal to 9 divided by 15, and then taking the positive square root of both sides of the equation to isolate a. Since the square root is the inverse or opposite operation of squaring, we get a is equal to the square root of 9 divided by 15, which as a decimal is 0.77459666692. So when x is equal to 4, y is equal to 15 times 0.77459666692 to the power of 4, which equals 5.4. And interpreting that result, we can say that 5.4 milligrams of medicine remains after 4 hours. Question 40, Part A. In a flock of 12,600 sheep, the ratio of males to females is 1 to 20. The weights of the male sheep are normally distributed with a mean of 76.2 kilograms and a standard deviation of 6.8 kilograms. In the flock, 15 of the male sheep each weigh more than X kilograms. Find the value of X. The first thing we need to find is the number of male sheep. Now it's given that there are 12,600 sheep in the flock and the ratio of males to females is 1 to 20. So to find the number of male sheep, we take the total number of sheep and we divide that by the sum of the terms of the ratio. So 1 plus 20 is 21, and that gives us the value of 1 part, and then we multiply it by the value of the first term of the ratio, which is 1, and that gives us the number of male sheep. So 12,600 divided by 21 times 1 is equal to 600. Now, out of those 600 male sheep, 15 of those male sheep each weigh more than X kilograms. So as a percentage, 15 divided by 600 times 100 is equal to 2.5%. So the top 2.5% of the male sheep each weigh more than X kilograms. Now, because they are normally distributed, we can use the empirical rule, also known as the 68, 95, 99.7 rule, to work out the value of X. The top 2.5% corresponds to 2 standard deviations above the mean. So looking at the normal distribution, this is the top 2.5% there. And that occurs above Z equals 2. So to work out the value of X, we take the mean, which is 76.2, and then we add on to that 2 lots of the standard deviation of 6.8. So X equals 76.2 plus 2 times 6.8, which gives us 89.8. Part B. The weights of the female sheep are also normally distributed but have a smaller mean and a smaller standard deviation than the weights of the male sheep. Explain whether it could be expected that 300 of the females from the flock each weigh more than X kilograms, where X is the value found in Part A. We worked out in Part A that there are 600 male sheep. Now, if there are 12,600 sheep in total, that means there are 12,000 female sheep. Now, out of those 12,000 female sheep, the question is, explain whether it could be expected that 300 out of the 12,000 female sheep from the flock each weigh more than X kilograms. So as a percentage, 300 divided by 12,000 times 100 is equal to 2.5%. And just like in Part A, 2.5% corresponds to a Z-score of 2. Now, since the mean mu is less than 76.2 kilograms and the standard deviation sigma is less than 6.8 kilograms, a Z-score of 2 for the female sheep would correspond to an actual weight that is less than 89.8 kilograms. Hence, less than 300 female sheep would weigh more than X kilograms.